Hello and welcome. My name is Jack.
My name is Alice.
My name is Sebastian.
Today we will be diving into a fascinating intersection of physics and plant biology. Magnetized water. Is it science or magic? It sounds like science fiction. Can running water through a magnetic field somehow improve plant growth? The findings have been fascinating. A 2024 study published in Results in Engineering set out to test exactly that. Ali Al-Akaris and his research team examined how exposing different types of water to a static magnetic field affected both the water's properties and the growth of two staple crops, wheat and barley.
So, what exactly is magnetized water?
Great question, Alice. Well, it is exactly as the name implies, water that has been exposed to a magnetic field. In this study, researchers applied a 0.15 Tesla magnetic field, which was relatively strong compared to Earth's magnetic field, to four different types of water: tap water, rainwater, distilled water, and deionized water, to measure if different intervals of time had a different influence on the wheat and barley. Water was exposed to the magnetic field at varying lengths of time, from 5 minutes up to 25 minutes, with a control of 0 minutes.
How did the magnetic field impact the water?
Now, here's where it gets interesting. The magnetic field did not change the molecular structure of the water, as the water was still two hydrogen atoms bound to an oxygen. This was determined and confirmed experimentally.
So, if the water molecules did not change chemically, what is changing?
The physical properties of the water changed. The pH, or the amount of H plus atoms floating around in the water of distilled, deionized, and rainwater, increased, in some cases dramatically. The water's ability to conduct electricity, its ability to allow electrons to pass through it, changed, and the total dissolved solids also shifted in distilled water. Thus, while the molecules of water themselves did not change, they were not chemically altered. The exposure to the magnetic field influenced how they behaved electrically and structurally. After magnetizing water and measuring its properties, researchers used it to germinate wheat and barley seeds under controlled lab conditions. They measured germination percentage, root and shoot length, fresh and dry weight, vigor indexes, and water uptake.
So, what were the results?
Excellent question, Sebastian. Let's start with wheat. In some cases, magnetized water significantly increased seedling root fresh weight and shoot fresh weight. For example, deionized water treated for 10 to 15 minutes led to noticeable improvements in root growth, suggesting magnetized water may enhance early growth in wheat under certain conditions.
How did magnetized water affect barley?
Well, barley told a different story. Although deionized magnetized water slightly improved germination rate, other growth parameters like shoot length and vigor index actually decreased with certain treatments. In other words, what helped wheat sometimes hindered barley. And importantly, many core metrics, including total germination percentage and overall water uptake, showed no significant change at all. This wasn't a dramatic agricultural breakthrough, it was a subtle species dependent effect.
Why would this happen?
Well, Alice, the researchers suggest that the key lies in the change to water pH and electrical conductivity. We know from past research that most seeds germinate best in a pH between the range of 6 and 7. In this experiment, magnetization pushed some water types outside that optimal range, depending on exposure time. If magnetized water shifts pH towards an optimal condition for wheat, you might see improved growth. But if the same shift moves barley outside its comfort zone, growth could decline. There's also speculation that the magnetic fields may influence hydrogen bonding in water clusters, ion polarization, and possibly even enzyme activity within the seeds.
What does this all mean?
First, magnetized water does appear to alter measurable physical properties of water, especially pH and conductivity. Second, those changes can influence plant growth, but not universally and not always positively. Third, exposure time matters. The most noticeable changes in both water properties and seedling growth occurred after about 20 to 25 minutes of magnetic exposure. And finally, this study was conducted under controlled laboratory conditions. The authors emphasized that more research, especially field studies, is needed before magnetized irrigation can be recommended at a large scale. Magnetized water isn't magic, but it's not pseudoscience either. It's a subtle physical intervention that changes water chemistry in ways that may influence plant biology, sometimes positively, sometimes negatively. For wheat, there were promising signs. For barley, the story was more complicated. And overall, this study highlights something important. Even small changes in physical conditions like pH or ionic balance can ripple through biological systems in complex ways. As agriculture faces increasing pressure from climate change, water scarcity, and soil degradation, low cost physical treatments like this are worth investigating.
This was Alice.
This was Sebastian.
And this was Jack. Thanks so much for listening, and I hope you enjoyed this deep dive into magnetic fields and plant biology. Thank you.